Hello PLP Geometry, welcome to the 6th installment of Unit 5. So let's recall that Unit 5 is broken into two parts. We started talking about parallelograms, and now we are well into the coordinate plane in this coordinate geometry. So number 6 here is going to talk about distance, perimeter, and area. Okay, so in today's video, and there will be two, so this is 6A, we are going to talk about the distance formula, finding distance, and then we'll introduce perimeter and area, and I'll do some examples on the second video. So distance on a coordinate plane. So distance on the coordinate plane. This is a huge deal for the state test, right? And now you've actually done this stuff before. Whether you remember it or not, you did it back in middle school. Okay, I know for a fact, okay? But again, state test loves this stuff. So let's say I give you 2 points on a coordinate plane. Let's say I give you point A, very similar to like what we do at the midpoint. So this is point A, and since it's the first point, say it's at coordinates x1, y1. And let's draw this diagonal segment. Here's B, which has coordinates of x2, y2. x2, y2, because it's the second point, right? So the distance I want to find on this coordinate plane is that distance d. And unfortunately, right, when it's diagonal like this, we can't count. If it's vertical or horizontal, we definitely can count, and we should count. But here we can't count. So how in the world are we going to find this distance? Well, there is a formula, right? So to find the distance d, which is the length of AB, you can use this formula. So you can do in parentheses x2 minus x1 squared plus y2 minus y1 squared, all of that inside the square root. So if you were someone who can do a formula and not mess up, I would go ahead and do that. Okay? However, I do not teach it like this because there's a lot of things to mess up when you plug in. So I do it this way, and I'll make it in green. Or I just use Pythagorean theorem. Now you're saying, how can you use Pythagorean theorem? Well, if you look over here, I can easily make a right triangle by drawing a horizontal to the side and dropping a vertical down. Right? See this right triangle? Now, you know Pythagorean theorem, right? So if I take a look at this picture, let's let this bottom side be x, and it would just be how many it is side to side, which you can count. Let this vertical side be y. So we can just use Pythagorean theorem. I'm just going to shorthand. So Pythagorean theorem, again, says a squared plus b squared equals c squared. In this picture, d would be c. I'm going to let x be a and y be b. So it would be x squared plus y squared equals d squared. And then to get d by itself, I would just take the square root of both sides. And this is the formula that I would use. D equals the square root of x squared plus y squared. Again, this is a formula I'm making up based off the Pythagorean theorem, but to me, it's a Desmos, graphing, and Pythagorean theorem question. So that's what I would do if I were you. But if you want to use the formula, that's what Delta Math is going to show you. You go for it. All right, so let's do an example of finding distance on the coordinate plane. Okay, so this is our example here. We'll call it example 1 because this is the first example. So we're going to find distance. Find distance between, and our points are going to be 5, -8, and negative, and -3, -1. So again, right now, I'm going to use Desmos to graph my picture. Okay, so I'll finish this problem on Desmos with us. So I'm using Desmos to graph my picture. So 5, -8, -3, -1. So if I go here, so 5, -8, -3, negative 3. If I could type, comma, negative 1. Okay. So 5, I have to zoom out one time, sorry. Okay, so there's my 2 points. So 5, negative 8, and negative 3, negative 1. So on my paper, I would draw a coordinate plane. I hate how it gets so big, right? The default settings on this annoying sometimes. Okay, so I draw my coordinate plane, and I would go 5, negative 8, and then I would go negative 3, negative 1. So there's my 2 points. So now I'm going to create a right triangle, right? Down and to the right, because I want, and I guess I should have done the reverse, I want this distance. And again, I did not graph it, so it would give me that picture. You can use that polygon command we talked about to get that, but that's what I'm looking for. I'm looking for this distance. So again, I draw these, and I want to find the x and the y change. So that's easier for me to count on Desmos. So I'm going to count down and to the right. So when I go down, I'm going down 1, 2, 3, 4, 5, 6, 7. I don't care about the sign, just 7. So my y is going to be 7. And I go to the right, 1, 2, 3, 4, 5, 6, 7, 8. My x is 8. So now I'm just going to use my simple formula, d equals the square root of x squared plus y squared. D equals. So I'm going to put 8 in for x, 7 in for y, and take the square root. And you can type this into Desmos all at once. Now, if you want to simplify it first, right? So we get the square root of, this is 56 plus 49. 56 plus 49 is 105. So it is the square root of 105. But then we just type it in Desmos. And again, you can type any of these in. Again, you can type in, like I said, so you can type in square root, and I'll find it for you right here. Let me move this out of the way. So the square root is right here, square root of 105. Okay, you get 10.24. Oh, I made a mistake. Time out. Whew, I made a mistake, sorry. 8 squared is not 56. 8 squared is 64. Whoa. Come back here. So 8 squared is not 56. 8 squared is 64. So this is not 105, it's 113. I apologize. My bad. So please, hopefully you made that change with me, okay? I don't want you saying you're math teacher can't do math, right? Mistakes happen. So back here, so we can do the square root of 113. Okay, so you get 10.63, and again, if it wants it to the nearest tenth, which I think it will, so this distance was 10.63. The 3 does not change the 6, so 10.6. And like I said, you can even go back, so that you don't make the mistake I make, you can even go square root of 8 squared plus 7 squared. And it does it back there too. So you don't need to simplify if you don't want to. So this is how we find basic distances on the coordinate plane. So we are going to use this to help us find perimeter area in the next video. So stay tuned for that.